Hello everyone, this is Sri Guru over here. Welcome back to my YouTube channel. Today in this video we are going to discuss about relative velocity. Relative velocity. Look at the name. Relative velocity. That means if we consider the two objects are moving, right, then whenever we are telling the velocity of any moving object, always we consider the frame of reference as a ground. With respect to ground, we are telling the velocity of that moving object. But here in this case we have to consider the two objects which are moving. Then the relative velocity of one object with respect to the other object. What is that and how we can calculate? In this video we are going to discuss about that. Okay. First, now see here. First write down the definition. Just simply note down it rather than writing. Just remember, velocity of one object with respect to the other object is called relative velocity. The time rate at which the displacement of the one object with respect to the another object, this is what we call relative velocity, right? Okay, let us consider there is frame of reference here, the 0, correct? The object A is at here. The object A is at here, correct? Object A. And the position of this object is x0, 1. x0, 1, right? And there is another object B, and his position is x0, 2. The both object A and B are at rest. That means, at a time t is equals to 0, the object A, B positions are x0 with respect to the origin, and B object position is x02 with respect to the A. When their time is 0, their positions are here. Now A and B are moving with a velocity, certain velocity. The object A is moving with a velocity v1, correct? And object B is moving with a velocity v2, correct? After certain interval of time, the object A reach at here, at this position, right? And the position of the particle A is x1. Remember, x1. Is it right? Now, the object B, after the time interval t, B reach this position, and that position from the origin is x2. Now these two are at time t, at a time t, correct? Note down here properly all the points. When the time t is equals to 0, that means their initial position with respect to the origin, the object A is at x01, correct? And after certain interval of time, the A reaches after certain interval of time at here at a time t, and that position is with respect to 0, x1, correct? And the object B initial position is x02 from the origin, and after certain interval of time the B reaches at here at a time t, and that position is x2. Note down here or take the snapshot initially. Okay, I hope now you all the you term all these terms properly. Okay, what this x01 displacement of A at t is equals to 0 from the origin, and x02 is displacement of B at t is equals to 0. Correct? x1 is displacement of A at t is equals to time t, and x2 is displacement of B at t is equals to t. Correct? Now the displacement of A from here. Okay, now the displacement of the object A, the displacement of object A in a time t. What is that? Then how we can calculate this? Now see here, this is x1, correct? And x1 minus x01, right? This is equal to, the object A is moving with a velocity v1, therefore we can take this as v1 into time t. Remember this properly, or otherwise rearrange this. x1 is equals to x01 plus v1 into t. Is it right? Similarly, the displacement of object B in a time t, final position minus initial position. Similarly, x2 minus x02. If we do this, then we will get this displacement, correct? Then x2 minus x02, the object B is moving with a velocity v2, therefore it is v2 into time, correct? v2 into time is nothing but what? It is a displacement only, right? Now, or otherwise x2 is equals to x02 plus v2 into t. Okay. Now this is equation 1 and this is equation 2. Correct? Then what we need exactly? Subtracting 1 from 2. Subtract equation 1 from 2. Okay. Do this. Then we will get relative displacement, right? Then x2 first minus x1. This is equal to x02 minus x01. This one, correct? Next, V2 minus V1 into T. Correct? Note down this properly without fail. Okay? All the terms are now right. See here, this but x2 minus x1. x2 minus x1, what that gives? The relative displacement of this x. Correct? Relative displacement x. And x02 minus x01, that means x02 minus x01 means this relative distance between A and B, x02 minus x01, this is nothing but their initial position of the object. Replace this with x and replace this x02 minus x01 with x0, their initial position. Therefore, this equation become x is equals to x0 minus plus V2 minus V1 into T, or otherwise V2 minus V1 is equals to, first take this to the left side, x minus x0. Now take this T to the left side, then it becomes, it goes to denominator T. Correct? Is it right? Now remember this equation. Okay, or otherwise take the snapshot of this board. Just simply this equation represents velocity of one object with respect to the another object, or just velocity of object B with respect to object A. Correct? Or VBA is equals to VB minus VA. VBA, that means velocity of object B with respect to A is equal to velocity of object B minus velocity of object A. How we can use this practically? That is what we are going to see next. Okay, first take the snapshot. See how we can use this concept practically. Let A and B are moving with the velocities VA and VB respectively in the same direction, in the same direction. That means if this is the object A, correct, and this object A is moving in this direction with a velocity VA. Similarly, there is an object B and it is moving in the same direction with a velocity VB, correct. Then velocity of B with respect to A is VB minus VA. Then this AB object velocity increases with VBA. What the tail of this arrow is representing? This is representing what? The magnitude value. When you add this, then you will get this one, not this one. Okay, it reduces here. It reduces somewhere like this. Okay, this is VAB. Sorry, VBA. Is it right? Correct. Now, if you want to write velocity of A with respect to B, then it is VA minus VB. Is it correct? If VA is equal to VB, if VA is equal to VB, that means object A and object B are moving with a same velocity, then VBA is equal to 0. Relative velocity is 0, or this VAB is 0 with respect to each other. Correct? Is it right? If A and B are moving in opposite direction. If A and B are moving in opposite direction, that means this here, A is moving along the direction in the positive x-axis with a velocity of VA, correct? And the object B is moving opposite to the direction of A with a velocity VB, correct? Then now see here, it is moving in the negative x-axis, therefore it must be negative, correct? Then VBA. What is first? If you want to write here AB first, velocity of A with respect to B, VA minus into bracket minus VB. Velocity of A with respect to B, that is VA minus of minus B. Then it is VA plus VB. VA minus of minus plus, therefore VA plus VB. When the objects are moving in opposite direction, we should add the relative velocity, correct? note down all these points. Okay, next one here. If the object are moving in the same direction and if you want to write the position time graph for that relative velocity of that object. Position time graph. As I said here, if their relative velocity is 0, that means VA is equal to VB, then the graph is like this. Along the y-axis, we are choosing the position, and along the x-axis, we are choosing the time. And this is the origin. As we seen in the earlier diagram, if their initial position with respect to the origin is certain at the time t is equals to 0, at here, right, without intersecting, they should move like this. They are parallel. Correct? Is it right? Correct. If their relative velocity is different, if this is not equal to VA is not equal to VB, or VAB or VBA is not equal to 0, then the graph should be, the position time graph should be P, and this is X, and this is the time, and this is the origin. Then the first line is, and the second one is like this. Okay, this line, this shows that the object moving with a faster, and this object moving slowly, right? Just remember, because this intersection, this means, this shows that at a particular point A and B are, when they are moving in the same direction, they meet at a certain point, at a certain position. Okay, this is the meaning of that graph. Remember. Okay. Okay, thank you for watching my video. Don't forget to like and share and subscribe. In the next video, we will solve some numericals based on these concepts. Thank you.